Hello all, I hope you all are doing well. Today we are going to see how to apply the Dijkstra's algorithm. Dijkstra's algorithm meant for finding the shortest distance of source node from any other node from the given graph. This is the given graph with total 6 vertices A, B, C, D, E, F. The first step to find the shortest distance from the source node to any other node is to prepare the adjacency matrix. Now from the nodes, distance from itself should be considered as 0. So A to A, B to B likewise, that distance has met 0. If direct path is available, then the edge weight is going to be used for representing the distance between the pair of the vertices. Here A to B direct edge is available, so that distance is specified here. If the direct path is not available, see here A to E, no any direct edge is available, then in that case also we have to put 0. So this way adjacency matrix should be prepared. Now first step is over. So with second step we have to initialize the distances and status of all these vertices which are the part of graph. So total 6 vertices are there. We have to make the distance infinity for all. That represents that the shortest distance is unknown. Status is representing whether this vertex is processed or unprocessed. So it is initialized with 0 value. Initially all the nodes are unprocessed one. Moving with the step 3, we have to select the source node and we have to make its distance 0. So here we have chosen A as the source node. So Dijkstra's algorithm is going to give us the shortest distance between A and B, A and C, A to D, A to E, A to F. So source node has been selected. Its distance should be made 0. So that's what did here. Its distance is made 0. Now step 4 is the iterative step where we have to select the node with least distance, and the another condition is that it should be unprocessed one, and from this selected node we have to look for the nodes which are reachable from this selected node, and its distances should be updated by using the adjacency matrix. So here the distances will be compared. Okay, from this step 3, these distances will be compared, and it will find that A is with minimum distance. So its status will be updated to the 1. Now it is being processed. Now from A, whatever nodes are directly reachable, its distances we can update. So the nodes which are directly reachable from A are B, C, D. From this graph also you can confirm it. A to B, A to C, A to D. There are respective values in the adjacency matrix. So it represents that direct path is available between these vertices. Now A to B distance is 3 and 3 is less than infinity, which is the initialized value. So this infinity will be replaced by 3. A to C is 1, which is also less than infinity. So this is replaced by 1. A to D is 6, which is also less than infinity. That's how this infinity is replaced by 6. So that's how our first iteration is over. With second iteration, again we have to look for the distances of all the vertices, and we have to choose the node with minimum distance as well as its status should be the unprocessed one. That is, its status should be 0. We are not going to consider A even though it is having the least distance, because it is processed node, and when it is processed its distance is already finalized. Okay, so we should not update it. On comparing these distances of all vertices, it finds that C is with least distance and its respective status is 0. So its status is updated to 1. Now it is being processed. So from C, the nodes which are directly reachable are considered for updation of its distances. Now B, we are not going to consider A as its status is processed, so its distance is already finalized. Now B is reachable from C. BC distance is 5 and C is at distance 1 from the source node. So the distance of B becomes 6. But this 6 is greater than 3. So this newly calculated distance we cannot use for replacing this 3. We should retain this 3 as it is less than 6. Next, now D is at distance 5 from C and C is at distance 1 from source node. So 5 plus 1 is 6 and D is already at 6 distance, directly reachable from A. As it equals, we are not going to replace this value. Now E is reachable from C, which is at distance 6 from C, and C is from one distance. C is at one distance from the A. So total distance of E becomes 7. 7 is less than infinity, so infinity will be replaced by 7. Similarly, F is at distance 4 from C and C is at distance 1 from A. So total distance, this F, the total distance, this F lies from A is 5 and 5 is less than infinity, that's how infinity is replaced by 5. Now all the nodes which are reachable from C are considered here. So with this, the second iteration is over. While moving with the third iteration, again all these distances will be compared. Here we find that A and C have been processed one. So we have to choose the node among B, D, E and F which is with the least distance. So B is with least distance, so its status has been marked as 1 as it is being processed. Now we will look for the nodes which are reachable from B. So nodes which are reachable from B are A, C and E. A, C, E, these are reachable from B, of which A and C have been already processed. So only node remained is the E. E is at distance 3 from B and B is at distance 3 from A. So total distance of E from A is 6. And currently E is holding 7 value. So 7 is greater than newly calculated value. So this newly calculated distance could be used to replace this 7. So that's how this E's distance has been updated to 6. Now all the nodes which are reachable from B have been processed. So that's how third iteration gets over. Now with the next iteration, again we have to look for the nodes which are unprocessed and we have to choose the node which is with least distance. So F is going to be chosen here. Now its status has been updated to the 1. It shows that it is being processed. Now check for the nodes which are directly reachable from F. Now directly reachable nodes from F are C, E, D, of which C is already processed. Check for the D. Now D is at distance 2 from F. F is holding 5 distance, so that is the distance from the source node. So 5 plus 2 is 7. D is at distance 2 from F. F is at distance 5 from the source node. So 5 plus 2 7. D is holding 6 distance. So newly calculated 7 value is greater than 6. So we are not going to replace it. We are going to retain this value. Coming to the E node. E is also directly reachable from F, which is at distance 6. F is at distance 5 from the source node. 5 plus 6 is 11. E is holding 6 value. So we are not going to replace it. Instead, we will retain it. Okay. So that's how the C, D and F, which are direct C, D and E, which are directly reachable from F, these nodes have been processed. So this is how this iteration also over. Now again the same procedure will be repeated. While moving with the next iteration, from the earlier iteration, the distances will be compared of the nodes which are unprocessed one. Now D and E, only two nodes are there which are unprocessed and are of equal distance. So any node randomly could be selected for processing. Now D has been selected and its status has been changed to 1. So now this is being processed. So we'll look for the vertices which are directly reachable from this D. Now from D, the directly reachable vertices are A, C and F, of which A and C have been already processed. A, C and F all have been already processed. So this is how this iteration gets over. We are not going to change the distance of any of this node, because already the distances for all these nodes have been finalized. Now with the last iteration, only E node is remained, which is unprocessed one. So that gets selected and its status gets changed to the 1. Now if you check for the nodes which are directly reachable from E, B, C, F, all these nodes have been already processed. So with this iteration gets over and we come, we end up with shortest distances of all nodes from the source node. So B is at 3 distance from the source node, C is at 1 distance from the source node, D is at 6 distance, see here, D is at 6 distance via C, A to C is 1, C to D is 5. And for getting this path up to the source node, if it is reachable via any other node, then you may use one more variable, intermediate node or preprocessor, so with which you can keep track of the parent node. Next is the E node. E node is also at distance 6 from the A node via B. A to B is 3, B to E is 3. So that's how it is 6. Next is the F is lying at distance 5 from the source node by following the path A to C, C to F. So that's how Dijkstra's algorithm works in order to provide us the shortest distance from the source node to any other node from the given graph. Thank you.